All right, today's lesson is 5-3. It's rate of change and slope, and our objectives today are to be able to find the rate of change and slopes, and then to relate a constant rate of change to the slope of a line. And there are 6 examples. We're going to do 5 of them on your video and 1 of them in class. All right, you should have your handout ready to go. On the very first top, it says rate of change, and you'll see this equation for rate of change. It says rate of change equals the change in the dependent variable over the change in the independent variable. And it says, read this as a rate of change is a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable, and it's also known as slope. So here we're going to fill in for slope. So on your notebook or on your note sheet, you're going to fill in these blanks. Slope equals. All right, so you're going to copy this definition onto your note sheet. It says slope is the change in y over the change in x, and that equals, and this is a little delta sign, it just stands for change in. It's just a shorter way of writing this. So delta y over delta x, and that also equals what you guys are used to seeing, rise over run. So fill in all of those blanks before you move on.
All right, so number 1 says find the slope of a line that contains 0, -3, and 4, and +3. So you can see what we've done here is we have graphed this line for you on this graph, given the points 0 and -3. We plotted that point right here, and 4 and +3, and we plotted that point right here. After that, we drew a line to connect the two. And now we're going to show you how to find the slope given 2 points. The first thing you're going to do is pick a point and count vertically. So you're going to count up or down vertically. I'm going to start here at 0, -3, and I'm going to count up. 1, 2, 3, 4, 5, 6, and you can see that I'm on track here to connect with this line, so I'm going to stop there, and that means that my rise is 6. I'm going to run 1, 2, 3, 4, and so my run is 4. That reduces by 2 to 3 over 2. I can also start at this point and count down. 1, 2, 3, 4, 5, 6, which gives me -6, and back 1, 2, 3, 4, which gives me -4. -6 over -4, a negative divided by a negative is positive, so that reduces as well to 3 over 2. And gives me the same thing either way I count, if I go up and over or down and back. So again, it's my rise over my run, and that is how you find the slope of that line. Make sure that you have drawn your lines here on your graph and written your slope in both forms over here to the right before you move on. You can pause the video if you need to. On number 2, this line has been given to us in slope-intercept form. It's in slope-intercept form, and y equals mx plus b. Your mx is going to be your slope, your m is your slope, and your b is where it crosses the y-intercept. So you can see this line is crossing the y-intercept at 3. It's already graphed for you, and we've given you the points -6 and 5, and 3 and 2 on the line. So again, we're going to find the slope of this line by counting the rise over run. So I'm going to begin at one point and count vertically. I'm going to start here, my negative 6 and 5, and I'm going to go down 1, 2, look, 3. Okay? So my rise is going to be negative 3. And then I'm going to run until I get to that other point. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is a positive 9 because I moved from the left to the right as I counted. So that's going to reduce down to negative 1 over 3. Now I can go the other way and start at my 3, 2 and go up. 1, 2, 3, which gives me a positive 3. And then back 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9, which equals negative 1/3. So either way, my slope is going to be negative 1/3. And again, I can look back up here at my slope-intercept form and see that negative 1/3 is the slope of this line, so I am correct. Make sure that you have your lines drawn on your graph as well as your two forms of the slope written over here. Before you move on, you can pause the video if you need to. All right, number 3, you may notice, looks a little bit different than the other lines that we have just done. It only goes up. It doesn't go over at all. So we've been given the points 3, 4, and 3, negative 2. And obviously, just like with the other ones, we're going to begin by counting vertically. So I'm going to start at this point, and I'm going to go up 1, 2, 3, 4, 5, 6. So my slope is going to be 6 over. And if you'll notice, I don't go left or right at all. So I'm moving 0. I'm moving 0. And if you try to divide something by 0 in your calculator, it's going to tell you that it is an error or undefined. So my slope here is undefined. So you need to write the word undefined there. Because no matter what, if I divide anything by 0, it's going to be undefined. So that's what we call the slope of this line. It doesn't matter if I count down 1, 2, 3, 4, 5, 6 and get negative 6 over 0, it still equals undefined. Okay, so flip your paper over. You're looking on the back now at number 4. The first thing we do is we count vertically, and you may notice with our points, negative 4, negative 3, 1, and negative 3, there is nowhere to go vertically, so my rise is going to be 0. My run, 1, 2, 3, 4, 5 between the given points, or 1, 2, 3, 4, 5, or 0 over negative 5, either way. 0 divided by anything equals 0. So the slope of this line is simply 0. Make sure that you have all that down before you move on. I want to go back and review one thing with you very quickly. Okay. Back to our first line. Notice that my ultimate slope came out to be positive. It came out to be positive. And notice that my line has a positive slope. When we were talking about correlations and lines going up, we talked about how if it goes up, it's positive. If it goes down, it's negative. So my slope is positive. So that should be an indicator when my line goes up, it's a positive slope. So if my slope, if I don't find a positive slope, then I've done something wrong. On number 2, you've probably already guessed by now, my line is going down. My slope should be negative. So again, if I don't find a negative slope here, I've done something wrong. Again, here on number 3, my slope is undefined. Anytime you have a vertical line, a line that goes up and down, it is going to be a slope of undefined. And then anytime you have a horizontal line, like you do in number 4, you're going to have a slope of 0.
Alright, just like Ms. Fielden was just explaining, we're going to go back and look at this chart here, and it says, as shown in previous examples, slope can be positive, negative, 0, or undefined, and you can tell which of these is the case by looking at the graph of the line. Here, left to right, the line goes up, so it's positive. Here, left to right, the line goes down, so it's negative. Anytime you have a horizontal line, your slope is 0, and anytime you have a vertical line, your slope is undefined. There's a couple different ways to remember these because we have a tendency to get the 0 slope and the undefined slope mixed up. We're pretty good with the positive and negative, but the 0 and undefined, we have a tendency to want to mix those up. We like to use a skiing example, saying that you can, on skis, go up a hill, you can ski down the hill or slope, you can ski side to side on level ground, but you cannot ski going up and down. If so, that means you're going down a cliff and you're going to go splat and you're going to be undefined. So again, that's just a kind of little simple way to remember that undefined is your vertical line and 0 is your horizontal line. We also think about a car can go uphill, downhill, kind of the same deal. A car can go side to side. A car cannot go straight up and down, so it is undefined because it cannot happen. Okay, again, just several different ways to remember which one's which with those. Okay, we're going to look at example number 5. Example number 5 says, Leah's cat climbed a tree and will not come down. Her dad places his ladder against a tree so that the top is near the cat. The top of the ladder is 10 feet above the ground, and the bottom of the ladder is 4 feet from the tree. Dad climbed the tree and rescued Leah's cat. It says, draw a diagram to represent the situation. So that's what I've done here. This is my diagram to represent my situation. I've got a cat, I've got the tree, I've got the ladder and the dad, and there's little Leah. Okay, again, if you're asked to draw a diagram, it does not have to be in quite that much detail, but you do need to draw yourself a picture of what's going on. And then part B says, what is the slope of the ladder? Well, here it says it's 10 feet above the ground. So that means from the top of the ladder to the bottom of the ground is 10 feet. And then it says that it's 4 feet from the tree. So from the tree to the ladder, I guess that should be more here, but I wanted you to be able to see it, is 4 feet. Okay. So this is basically my rise of 10 feet, and this is basically my run of 4 feet. So we're going to say that the rise, or the change in y, again, delta y, is 10, because it's going 10 feet up. And the run, or the delta x, or change in x, is 4, because that's right here. We're going to go 4 and up 10. Okay, so we're going to have a slope of 10 over 4. Now I can't leave it as 10 over 4 because that can be reduced, and anytime a fraction can be reduced, it should be. So if you don't know how to reduce a fraction and you have your graphing calculator, you can hit the alpha y equals fraction button and you can put in your 10 over 4 and hit enter, and it will actually reduce that fraction for you. But here both 10 and 4 can be divided by 2 and you get 5 over 2. So my slope here is 5 over 2. Okay. Now, sometimes we look at this and we're like, okay, well that's going down, so it should be negative. However, if I were to put the ladder on the other side of the tree, then it would be a positive slope. And since this is a real world situation talking about feet, it does need to be positive. All right, take a minute, make sure you have all that down. Okay. You do have number 6, so you're going to need to make sure you bring these notes, and we're going to finish number 6 in class tomorrow. Alright, so back to our objectives. We should now be able to find the rate of change in slopes and relate a constant rate of change to the slope of a line. That's what we're going to do with number 6 tomorrow. That is the end of your video. Thank you for watching.